Hello, everybody. Good morning and good evening. My name is Hong Yuan. I'm a project management project director, or maybe we can call it the program director in UNDP Beijing office. We are working for the environment implementation of environment conventions for China. I have working in the environment field for more than 20 years. Today, I would like to introduce some environment programs, environment conventions in China. Today, I would like to introduce some information related to international conventions on the climate change. Everybody, you have maybe know there are many environmental conventions in the world. First, we would like to we would say the UNFCCC. The convention was adopted in 1992 and entered into the force in 1994. And we have another conventions related to the climate change. That is Kyoto Protocol. The protocol was established in 1997 and into force in 2005. And also we have a Paris Agreement. The agreement was adopted in 2015. It aims to strengthen the global action on climate change by limiting the increase in the global average temperature to below 2 degrees Celsius and working to limit it to 1.5 degrees Celsius. We also have another environment conventions for protection of the ozone layer. I think everyone, maybe you know the program for ozone layer protection. The ozone layer, it is derived from the VLA Convention for protection of ozone layer. The protocol, the convention was signed at VLA, so we called the VLA Convention for the protection of ozone layer. And based on the VLA Convention, the parties of the countries, the parties of the VLA Convention held the meeting in Montreal Protocol, and we have adopted another the Montreal Protocol under the VLA Convention. The Montreal Protocol was signed in 16 September 1987, and the protocol was amended, and on the 20 August 1992, and we in the amendment we have made some adjustments and amendments. So respectively in 1990 or 1991. The Montreal Protocol stipulated the species such as CFCs will be phased out by 2010, and eliminate or phase out actually CFC substances by 2030. And we also have the Kigali Amendment. Kigali Amendment is included in the hydrofluorocarbons, we call the HFCs, under the Montreal Protocol in Kigali, Rwanda. So I would like to introduce HCFCs, CFCs. So we have the list of CFCs, and you can see the CFCs, they have harmful to the ozone layer. We have used the ODP, the ozone depleting potentials, to describe the harmless of the CFCs, and also those substances are global warming gases. So we call the GWP. You can see from this, you can see the CFCs have a lot of GWP. So in the process to phase out CFCs, we are not only contribute to protection of the ozone layer, but also we have make the great contribution to the climate change. So this is also the list of CFCs under the Montreal Protocol. Because the CFCs is the artificial chemicals, and they are very harmful to the ozone layer. But now I would like to introduce some the CFCs use. CFC is widely used in the industries, but in the products covers various of our lives. For example, we have the CFCs for refrigerants. That is you can see from here, it is the refrigerants of CFCs and HCFCs. And CFC also used for the foam sector. This is the foam picture, and also extinguishes also used the CFCs like halon, halon 1211. Those kind of substances are very harmful to the ozone layer. And also in the refrigeration sectors, in China, the refrigeration sector divided into the two kinds of the refrigeration sector. First is AC, that is air conditioner, like this is air conditioner, and we also the air conditioner also we have installed in the vehicles like a car and a minibus, and we also have this kind of products is the commercial and industrial products, and for those kind of the equipment, they consume a lot, maybe 300 kilograms to several tons of CFCs. So CFC faced the the phase out sepsis timeline, then according to the Montreal Protocol, all the sepsis was eliminated before 2010. After under Montreal Protocol, we also have with the development of the process to phase out sepsis, we also have some amendments to the Montreal Protocol. One is the Copenhagen Amendment. Copenhagen Amendment, which is which defined the timelines for phase out of H. sepsis. The timeline as following: 10% phase out in 2020, 30% phase out by 2025, and 60.5% phase out by 2030, and 90.5 phase out by 2040. This is the list of H. sepsis compared with the sepsis, H. sepsis ozone depleting, the ODP, ozone depleting potential is very low, but they are still very harmful to the ozone layer, because in the world, every year everywhere the world consumes about 1 million tons of HCFCs. HCFC, we also have HCFC also the global warming, have a global warming potential. For example, we have the HCFC 22, it is GWP is 1,810. It is also very big. Here is the HCFC in the list of HCFCs. We also have HCFC 141B. This is the GWP is 725. It is very of high GWP. In the list of HFCs, the main chemicals, it is HCFC 22 and HCFC 141B, because the HCFC 22 is used for the refrigerants, and HCFC 141B is for the foam sector. So in China, we consume that a lot. We about 300,000 tons to 400,000 tons a year. This is the I think the HCFCs. We also have another list. This is a list of HCFCs, and For other kind of edge services, the GWP is very low, but they have a scale GWP. Now, I would like to introduce the workers to phase out edge service in China. Because China have some new kind of technologies. China have China do some researches for now in China. We are doing the work to phase out edge services. We have in the household, in the air conditioner, the household conditioners, we use the hydrocarbon, the propane. That is if it is the according to the category for the refrigerant, that is called R290. 290. That is this is the hydrocarbon material. So the OWP is very low, and the ODP is 0. And this is now we many used for use R290 to substitute H7C22 in the air conditioner air conditioner sector in China. In the industrial and commercial refrigeration, now we mainly use the R32, and also we use some R32, and we also use some natural working fluid like CO2, ammonia, hydrocarbon, and also we have the HFOs. In China, we have a lot of projects in Haier Company, Meidi Company, Gree and Dalian Refrigeration, and Yantai Iceville Company, Dungan Environment Company, Hisense Company, and also we have phased out H7C 141B in the foam sector or foam panel. That is mainly for the foam panel. We also use some HCFCs as a clean agent. That is HCFC 141B for the clean agent in the solvent sector. Now this is the picture of the commercial refrigeration, commercial refrigerators, and this is the SE. The SE now the China we use the R290 for substitute H7Cs, and also this is the picture of the industrial and commercial refrigeration system. This is the foam sector, and we have the foam panels. Those kind of the foam agent is H7C 141B, because 141B have very high GWP. So when we phase out, when we doing the work to phase out HCFCs and HCFC, in the foam sector and the refrigeration sector, we are not only, as I said before, not only make the contribution to the ozone layer protection, but also make the contribution to the climate change. And also this is the foam panel for the refrigerator. This is the refrigerator, and the panel is they are including the foam. And also I would like to introduce the Kigali Amendment. Kigali Amendment is the Montreal Protocol. The Montreal Protocol Kigali Amendment, including the HFCs. The HFCs, actually the HFC is not ozone depleting substance, but HFC have very high GWP. So that is why the Montreal, because the HFC derived from the process to phase out HCFCs and CFCs. So HFC was included in the Montreal Protocol, actually specifically in the Kigali Amendment. The Kigali Amendment was adopted in October 2016 because at that time the parties of the conference, that is that we also called the corpus of the Montreal Protocol, was held in the Kigali, Rwanda. So we adopted this kind of amendment to Montreal Protocol. So we called the Kigali Amendment. Kigali Amendment, the main purpose of the Kigali Amendment is to phase out of HFCs, and it is also the response to the Paris Agreement, because now the climate change draw more and more attention in the world. So that is adopted the Kigali Amendment is the response to the Paris Agreement. And also under the Kigali Amendment, the energy efficiency is also a very important task for the Kigali Amendment. So the Kigali Amendment can make a very great contribution to the climate change. You can see, based on the Paris Agreement, the aim is to control the temperature increase by 2 degrees Celsius. But according to the estimation of scientists, the Kigali Amendment and the Montreal Protocol, if we phase out all the HFCs, CFCs, and HCFCs, we can achieve the target for target 0.5 degree Celsius. So that is the Montreal Protocol can make the contribution to the 1/4 or to 1/3 of the temperature reduction. So the Montreal Protocol is very important for the ozone layer protection, but also very important for the climate change. Now we would like to introduce some requirement for China to restrict the production and consumption of HFCs in China and also in Article 5 countries. What is the Article 5 countries? Because in the Montreal Protocol, we have definition for the definition for what is the Article 5 countries. The definition Article 5 definited the countries that consumption the ODS or HCFCs per capita. So we have so we also call this is the countries meet the Article 5 of the Montreal Protocol. We call those countries Article 5 countries. We also have other article. That is Article 2. Article 2 is they consumed more than that of the Article 5 countries. So Article 5 countries, we can, in other words, also most of them are the developing countries. So the Kigali Amendment requirement is like this: is freeze the production and consumption in 2024, reduce CFCs by 10% by 2029, reduce HFC 30% by 2035, 50% by 2040, and 80% by 2045. And if take the comprehensive consideration of Montreal Protocol, that means especially the Copenhagen Amendment and the Kigali Amendment. As I said before, if we achieved our aims by reduce HFC by 80% by 2045, and also if we also achieved 97.5% by 2040, the Montreal Protocol can reduce 0.5 degrees Celsius. So that is a greater contribution to the climate change. Now we have some. Now we have the list for the list of the HFCs. HFCs, you can see the HFCs, the OWP is 0, but they have a very high GWP. You can see from this figure, the GW figures data is very high. You can see, especially HFC 23, it is almost 15,000 tons. So that means 1 ton of HFC 23, it is almost 15,000 tons of CO2. So it is a very, very high GWP. But we also have another materials. This is HFC 134L. It is also almost 1,500 tons, 500 GWP. So it is also very high. So I would like to see now during the phase out CFCs. So in the automobile sector, we use the we use the R134A to substitute CFC 12 as a refrigerant in the car making sectors. So now in the world, all the cars use the HFC 134A as the refrigerant. So that is so it is very important to phase out to some of the work to phase out when R143A in the car sector, in the manufacturing of the car sectors. Now China, we also have we in order during the phase out of HFC process, China pay much attention to the climate change. So we use R32. R32 is we have a lot of air conditions use R32, but also in some commercial and industrial refrigeration system, we also use the R32 because compared with other kind of the materials, R32 have a lower GWP. That is 675. That is GWP. So it is lower. R22 is a product for in the process of production of HFC 22, HFC 141B. So we call it HFC 23 is a very important material for the climate change. So we must eliminate in the process of the production of HFC 141B and HFC 22. In China, we also, but also in the world, we also have some mixed refrigerants. Mixed refrigerant, we use some, for example, R404A, R406A, R407C, R410A. So those are also the mixtures. Because why we use the mixtures? Because the mixtures because the GWP of the material is some material is different. We use the mixtures to reduce the GWP. But we also you can see 404A and 407C, 410A. Those are the materials of HFCs, but the ozone depleting potential, the ODP 0, the value is 0. So, but they have the very great effects on the climate change. For the 406A, they also contain some HCFC 22. So that kind of the material has the ODP, so it is harmful to the ozone layer. But the mixture of this kind of refrigerants, it is it is have less ODP, but they still have a very relatively high GWP. So this is a picture. This is the kind of products from the China. And I think since most of the countries, students or colleagues, you are in the Latin America, so you have a lot of products from China, because China is the largest production of HCFCs and HFCs. China, the production from China is about 70%. 70%. China itself can consumption. China has the production of the HCFCs and HFCs. The total production volume is about 700,000 tons a year, and China can consume 400,000 tons, and 300,000 tons can be sold to the world, to Latin America, to the east, the countries in the eastern, Middle Eastern area regions. Now, I would like to, in order to phase out HFCs and HCFCs, China, we have doing some research on the natural gas, like some, for example, ammonia, CO2, hydrocarbons, and also we have the new kind of the material, HFOs. HFO is artificial or man-made materials. It is developed by Honeywell company in America, in USA. So the problem of HFO is they have the very zero OWP, but it still need to test its effects on the human health. And also HFO, the price for HFO is very high. For example, now in China, in IC sector, if we use HFO as the refrigerant, the consumption of HFO is now can cover the whole price of the other refrigerant. So in China, HFO, the price is very high. It is more than, I think it is more than 200,000 US dollar a ton. So you can see it is the price is very, very high. So that is also hinders the use of the HFO in the refrigeration sector and also in the foam sector. HFO can be used for refrigerants and also can be used for the foam agents. And we also have the mixture in order to reduce the price of the refrigerant and also the GWP of the refrigerant. We also have some China also cooperated with some other developed countries to develop some mixtures of HFO and HFCs. For example, we have this is the mixture of HFCs, HFCs and HFO and HFCs. I would like to to pay some attention to R134A. This kind of the material, it is a mixture of HFO and HFCs. So 134 now the 134A, it is HFO and 134A. So in this we can reduce the GWP of this kind of the material. For example, 134A have it is 56% lower GDP. You can see because the HFO, the GWP for HFO is 0, and GW for HFC, we also call this R134A. The GWP is 1,430. So if we mix that with use some HFO and R143A, so the mixture, the ratio is like this. So we can reduce the GWP is 800. So compared with more than 1,400, so it is much lower. So I would like to give you some introduction about the 134A, because introduction about the refrigerants, because the different refrigerants we are used in a different environment or different requirement about the temperature. For example, in the car, the temperature is about 20 degree. Even in the summer, we want the 20 degree Celsius L. So 134A is mostly used by the car. But if we in some sectors, some sectors like the freezing, the refrigerator and some chemical freezings, so the temperature requirement is minus 0 to minus 70, so very low temperature. So they use the different refrigeration systems, and they use the different refrigerants. Because 134A R513A is only for the commercial and industrial refrigeration sectors. Now, especially the technology we use in the screw compressors, not the other kind of the sectors. This is the screw sector, this is the rotor, and this is the assembly of the compressor. This is we call the screw compressor, because the compressor, different compressor used for the different purpose. Now I would like to take this opportunity to popularize some of the compressors. You can see from this picture, this is the piston compressor. Piston compressor is used by the refrigerator and small freezer and some products. This is piston. So this is the piston compressor. This is the screw compressor. This is a screw compressor. So I just give you some, but the screw and screw compressor used by the commercial and industrial refrigeration system. And also in China, in order to you have the green refrigerants, we use the CO2 and CO2 technology and ammonia technology. CO2 is non-toxic and non-corrosive, so and also non-flammable. So it is a good refrigerant. But the problem is the CO2 as a refrigerant, the pressure of the system is very, very high. So, but we can mixture CO2 and ammonia together and to have some new system. So that is China. A lot of engineering scientists, they work together to develop the ammonia CO2 cascading system. This kind of system to substitute the R22, and they are long. This kind of the system not only phase out of ODS or HFCs, but also get more than 15% of energy saving. In cascading system, the CO2 and ammonia, they have the separate refrigeration system and they working together to. This is ammonia. This picture shows ammonia and CO2 cascading system, and this is the ammonia. Ammonia now the temperature they make the lower temperature air. Then from here and those lower temperature will be used by the CO2. The CO2 in this system, CO2 also have act as the refrigerants because the CO2 can lower the temperature. So this kind of system is also used for the freezing sector. Because in China we have a lot of meat, vegetable. We have in the supermarket. We have a lot of meat and food need to be freezed. So by this kind of the system, this is a cascade. But we also have the CO2 as the secondary cooling system. For this system, the CO2 is not as the refrigerant. It is only take the cool produced by ammonia for the application. So now I would like to say something about the challenges of China. China is the world's largest refrigerants producer and manufacturer of refrigeration equipment. as you know, China SA last year, China have exported SA, the air conditioner, to the whole world. It is about 70 million units to the world. China also the largest refrigerant producer. We have not only produced the HFCs, but also produced the HCFCs. So China also exported a lot, also the largest export. So China faced a very heavy pressure from the implementation of Montreal Protocol, Kigali Amendment. And China also led to some researches and development of natural gas, like the ammonia, CO2, hydrocarbon, this kind of technologies in the different sectors. And also, as I said, in the HFO, currently we have because the price is very high, and also HFO have some harmful to the human health, so that need to be verified, to be tested. So HFO, so we still HFO, but we can use some in order to reduce the GWP of the refrigerants and the price of the refrigerants. We can use some mixture HFO as a refrigerant. So also China, we also have, because you know, in China, we have a lot of refrigeration system, like business center, malls, hospitals, schools, and big buildings. We also add a lot of refrigeration equipment used, not only in the north of China, but also in the south part of China. South part of China, they use this only for the refrigeration, but in the north, they also use this kind of the system for the heating production. So those kind of the equipment need to be the life of the equipment is about 15 years. So now in China we faced a lot of problem to reduce the currently existed refrigeration systems. So in the future, we have some important sectors. We have especially for the Kigali Amendment, because the HFC now is currently used for phase out HCFCs. So in the room air conditioner, we have a lot of products still using HCFC, and HFC, and we have a lot of industrial and commercial refrigeration. So in this kind of sector, we also is very important. And now in China, we have all the Chinese cars, automobiles are used the HFC or R134A as a refrigerant. And we also in China, the information and science, the computer science are very booming now. So we have a lot of data center. So the data center consumes a lot of any electricities, energies. So we also face the kind of those kind of problems in those kind of those industries. But for the Montreal Protocol, we are not only focus on the materials, but we also have we also pay much attention to the energy efficiency. You know, 1/4 of the power or electricity in China consumed by the in refrigeration industries in China. So that is very the occupation is very it is occupied a lot of electricity. So in China, the refrigeration sector is very important for the China to achieve the carbon peak and carbon neutrality target in China, and also substitution of the refrigerants. We are in the new products. We are using the new refrigerants, some new refrigerants, but also some of the equipment they have also the old equipment. They have some CFCs and HFCs still using the old equipment old equipment, and those old refrigerator equipment after its use at the end of life. So the recovery, recycle the existing refrigerants is also very important. So in China, we also have some local products to, for example, the AIIB and IDB, the Asian Development Bank, for this kind of the loan projects to use the green energy, green electricity, like the photovoltaic photovoltaic electricity or hydropower electricity to those kind of equipment. So I would like to say the ozone layer protection projects are closely related to the climate change. Energy conservation and emission reduction are important considerations in all international environment cooperation projects. So the GEB, that is global environment benefit in the projects, is included in the requirements for our projects. In other projects, we also encourage the enterprise in the innovation of the equipment or technology. We encourage the use of the green energy, like the hydrocarbon photovoltaic energies. Now I would like to give you the brief introduction about the projects about in UNDP China. For the first is phase out HFCs in industrial and commercial refrigeration sector. Now we are in stage 2, as I said in the introduction of Copenhagen Amendment. Now we are in the second phase. That is to phase out 30% of HFCs consumption by 2025. Now we are in the second phase. We have in China, we have got 32 million US dollar to phase out HFC in this kind of sector. We also have the second phase, stage 2 for the solvent sector. This is solvent sector. This is syringe. We use some we use some HCFC as the solvent in this kind of sector. This kind of this is the syringe production workshop. This is the syringe. They use the HCFCs. Now in China, we also have the demonstration of phase out of mercury containing medical thermometers and sphygmomanometers. So in the sector, in the medical sector, China, we need to phase out the mercuries by the 2000. The production of this kind of the thermometers and sphygmomanometers must be stopped from the beginning of next year. That is January 2025. China must stop. But in the market we can still, because we have some the products, some thermometers and sphygmomanometers still in use. But the new products will be stopped. New production will stop. This is the mercury, and this is sphygmomanometers also use the mercury. We also have the projects in the recycled aluminum, lead, zinc, and lithium sectors. This project is $16,000 US. This is this kind of this is the recycled lead, the lead battery in the company, the picture we tagged. This is the recycled aluminum. And in China now we also plan to have the projects for plastics sectors. So the plastic projects, we get the news in the 68th boarding committee of GEF will be held from the 16th December 2024. So the project will be approved actually this month. So we applied 22 million US dollar. But that kind of projects we will reduce the pulps and plastic pollution. So all those kind of the projects, the GEB, that including GWP was considered. So that is what I mean introduced about the UNDP projects and related to the conventions, international conventions for the climate, for the environment conventions and related to the climate change.